Welcome to all. This is part 1, lecture number 9. Now, first you have to make a note. We almost finished law of parallelogram of forces in basic application. Now, I would like to tell something else. Those who are going for, this is what I have covered is, from basic subject point of view, everything is covered. So that you get a complete structural, as you proceed further, study further engineering mechanics, strength of materials, structural analysis, later RCC, steel, etc. You will build up a very strong structural grip and your knowledge will immensely improve. But you have to go through the class. Every class you have to go through. And those who are going for depending only on the class, see, I don't want to mention again and again, that is not going for the notes. Then each and everything I tell here, you should write. Because I have seen morning, 10 o'clock, something told, 11:30, forgotten. Or you have to again and again go through the class. Therefore, what to do? As I tell the finer points all throughout this course, all subjects, see, 8-9 subjects are there. You have to go through the class and make all necessary notes. Effort is required. Of course, no doubt, it is possible. You require that much dedication. Now, see, first of all, make a note before you start. This I am telling repeatedly from earlier. When we apply law of parallelogram forces and the resultant expression R equal to root of P1 square plus P2 square plus 2P1 P2 cos theta and angle alpha 1 made with the force P1 equal to P2 sin theta divided by P1 plus P2 cos theta, or angle alpha 2 made by the resultant with the force P2 equal to tan inverse of P1 sin theta divided by P2 plus P1 cos theta. It is not by hearted. I can see everything. That expression is general expression. For applying that expression, it is compulsory that both the forces should either act away from the point or act towards the point. See, if the force P1 is here, acting away, P2 also acting away, then both, this is your angle theta. Angle theta. Then, see, when both are acting away, resultant also from the same point O, that also should act away from the point, this way. Resultant R, I am writing not much because already you know it. This is your alpha 1, this is your alpha 2. Then those expressions are valid. Or simple language, both forces should be outgoing, resultant also should be outgoing. Or you can even have both incoming, see. Both incoming. See, this need not be horizontal actually, P1, P2. Now also this is theta. Both are incoming. Then the resultant should also be incoming. R. Again angle same. Alpha 1 and alpha 2. Both are okay. Both are perfect. See here, when you make parallelogram forces, it will come this way and this way. Here, when you make parallelogram forces, see here, if it is this way and this way, you should see parallelly, this will come here, P2 will come here, and resultant will come this way. Or you can extend it also. You can extend and write also. So both are correct. Perfect answer will come. But note, you cannot apply the law in the format given by me, that is standard format, if one of the force is going away from the point and other force is coming towards the point. That is, if this force is going away, P1, I won't call P1, it's okay. And if other force is like this, see, like this question. Or if this force is coming here, this is going away. One of them outgoing, other incoming, or see here, outgoing, incoming, incoming, outgoing. You cannot apply. It will give wrong results, completely wrong results. Now, you will have a lot of confusion about angles. And resultant also, how to mark the resultant. I will tell one by one. Therefore, make a note when you apply law of parallelogram forces in the format given by me, which is actually standard format, both forces should be simple language, either outgoing, in that case resultant also should be outgoing, or both forces should be incoming, resultant also will be incoming. That is compulsory. Okay, now come to this question. See, question. Find resultant force for given force system using law of parallelogram of forces. Actually, remember, this I have not explained earlier. Actually, now it is better because why? Now you know everything, easy to understand. See, 60 Newton, 80 Newton, 75 degrees. Given question. Solution in the class right here. Yes, one of the force is going away from the joint, other is coming towards the joint, or one outgoing, one incoming. Yes, you write here. Class means I am telling you cannot apply the law of parallelogram of forces in the standard format. Some modification required. Okay, now I will first give wrong solution. Wrong solution means you write, suppose you apply, what happens? Suppose that see, I told you cannot apply. Still if you apply, what happens? I will show you. See here. Wrong solution. Take the 60 as P1, 80 as P2. Theta is 45 degrees. See, 75 degrees. Okay, then P1 here, P2 here. Resultant R, angle alpha 1, alpha 2. Nodi. Resultant R also doubt in the mind. See, I am telling now. Doubt. Resultant is this way or this way. See, here no confusion. Both are outgoing, resultant this way. Both are incoming, resultant this way. Crystal clear. Here. See, in the mind, murmuring. Resultant is this way or this way. And or, see, is it like doubt in the mind? Is it this way or this way? See, this way or this way. Okay. Anyway, okay, some way. See, some way. Let me at least find magnitude of resultant R. Why? Because I will write it. In so many structural applications, some connections problem solved, you get inclined, one force due to direct action, direct force, other due to twisting, bending moment or twisting moment will come. So forces will act this way. Then you require, direction is usually not required. That what angle resultant makes, they want finally usually bolt or weld. What finally force will come. Okay, you decide that way. Maybe, I'll tell you, see, okay, some way, let me at least find resultant. Because design person, he will tell, direction not required, whether resultant is this way or this way, does not matter to me. I want only magnitude. Then also wrong. Okay. Then resultant equal to 60 square plus 80 square plus 2 into 60 into 80 into cos 75. I wrote the answer, 111.735. Alpha 1 you know formula, alpha 2 you know formula, substitute, you get the answer. Then resultant is, see here, what is this? This way, okay, some way, 111.735. That also is wrong. And angle, something like this. Remember, this I wrote the answer, completely wrong. Resultant will be less than 111.735. Then some person will tell me, sir, okay sir, no problem. Why? Sir, resultant force I am taking 111.735, which is actually higher. How much real answer? Maybe around 80-90. I feel around 80-90 may be the answer. 1 minute now. Around 80-90, in that range. I don't know. 80-90. He will tell, okay, design purpose. Actual resultant force is around say 90. But I am considering 111.335. Safe? No. I am, see, suppose cost will come 90 rupees. You prepare for purchasing, you take money 111 rupees. That is, you be ready for purchasing around 112 rupees. But cost is actually 90 rupees. Safe. My answer for them, okay, what you told is correct. But remember, if one force is this way, 60, other force 80 is actually, see, it is incoming here. Suppose it is this way, then if you apply this way, you will get answer not 111, you will get much lesser. your resultant will come much lesser than the actual. Means you think expense is going to be 100 rupees, but when you go there, cost is 200 rupees. Safe then? Oh, then not safe, sir. You are estimating the force lesser. So do not tell this will give higher force safe. By applying this formula, sometimes it may give more than the resultant will come more than the actual value. Sometimes it can come less than the actual value. Anyway, completely wrong. Therefore, make a note here. This solution, what I have done is completely wrong, wrong, wrong. Even resultant also is wrong, wrong. This number and these angles will not appear. Okay, now I will not remove this one now. This will be there. As a warning for you, this will be there. Remember, wrong, 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 wrong. Okay, complete nonsense. I write here, nonsense. Nonsense answer. Okay. Then, what is the correct procedure? Wait, I will start now. I will solve. This I am not removing. Let the wrong value be there up to end of the class. I will write new and explain to save time. Where I kept the pen? Here, okay. Okay, now, right here. Now, correct solution. There are two options are there. Option 1 first I will take. See, option 1 is not recommended because little confusion. Make a note. Confusion for you. Don't include me there. Okay. Sometime in the class I will tell. Little confusion. Okay. For whom? Sir, for us, sir. For about me? No, sir. They know, not for me. See, these are all mathematical concepts. So, don't include me for confusion, right? For confusion for me, we, me. Me means when you write me, it is for you. Still, let us consider. Why? Curiosity. If I don't tell, someone will ask, sir, please tell, sir, what is that one? Okay. Make a note. We want, what all I am telling here, you are right. We want both the forces to be either acting away from the point or acting towards the point, either both outgoing or incoming. Again, you can make two solutions. One solution, you make what? Both outgoing, other incoming, not required. There is a limit for everything. Okay, start. I will consider both forces to be outgoing. You make a note here. Now I will modify this diagram. See, this diagram I am modifying so that both are outgoing. Someone will ask, what is outgoing call? Okay, mobile call. Both are outgoing. 60 is already outgoing. Simple, I will tell simple language. If someone tells outgoing, why can't you tell acting away from the point? Come and talk with me. I am seeing that things are clear for common people. See, I will use outgoing only. See, this is already outgoing. But this is incoming. What you want? This incoming 80, you want to go outgoing 80. See, I will change the direction. Instead of incoming, I will go outgoing. See, this is 80 this way. Minus 80 is this way. Don't tell minus 80 is this way. See, when you tell 80, it is this way. When you change minus 80, it is this way. See, if you remove the minus sign, it once again come back here. So, 60 you maintain as it is, right here. As it is. 80, you what to do? You reverse and use negative sign. So, now the question is, a right side, see, an outgoing force of 60 Newton, I will call P1. Again, outgoing force of minus 80 Newton, I will call P2. Resultant should also be outgoing. See, very important. When both are outgoing, resultant from the point should also be outgoing. Then only you get law of parallelogram forces. Okay, outgoing. Alpha 1, alpha 2. Okay, this is ready. Now, I won't waste my time telling resultant R equal root of that. All you write. If you want, somewhere write the star. I told what star means. Consider two forces P1 and P2 passing through a point O. Let R be the result, let theta be the angle between them. So here I'll tell you, your theta equal to how much? Your theta equal to 75 degrees. Or I'll do one thing. For substitution purpose, I write somewhere here P1 equal to plus 60 Newton, plus is not required. Your P2 equal to, substituting, minus 80 Newton and theta equal to 75 degrees. You write, then resultant is R equal to etc. formula right here. Start. 60 square plus minus 80 square, 2 into 60 into minus 80 cos 75. Resultant will come 86.691. I told earlier, around 90, 80 to 90 I told. Okay, I don't know, 86.691 Newton. This is correct answer. And alpha 1, I won't waste time. Tan inverse of, see, from here you want, minus 80 sin 75 divided by 60 plus minus 80 cos 75. If you want from here, alpha 2, 60 sin 75 divided by minus 80 plus 60 cos 75. If someone will ask how you got this one, I will tell better not come to my class. This is explained most probably more than 25 times now, formula. Okay, substitute. Both comes negative. I told you, when you get negative, add 180, write one more answer. If you get positive, keep quiet. Negative means you add 180 and get one more answer. Over. Now see, correctly observe now. Therefore, resultant as we got from correct solution only. This is not wrong. Correct solution, but option 1, which is actually not recommended. Right here. Not recommended. Because confusion. We will start now. Not because is as shown below. See here. First of all, remember, resultant, don't see this one. Resultant should be outgoing from the point. Okay, we got answer, 86.691. Someone will tell, sir, it is here. How you put here? Wait 1 minute. See, I will do one thing. I will use value of alpha 1 I got. I will use both the values today. See, I use both the values. Okay, use minus 63.046. We took alpha 1 from P1, see, like this. Don't tell clockwise positive, anti-clockwise positive. How you consider alpha 1? From the force P1, see, we consider anti-clockwise this way. Answer came negative. Oh, that means this is wrong. It is opposite, clockwise. So from here, go clockwise by 63.046. Again, from the point O, resultant should be outgoing. It can't be this way. It should be outgoing. Okay, over. This is one answer. Or suppose you want this answer also. Okay, no problem. Use it. From P1, we took alpha 1 to resultant this way. Answer came plus 116.954. But this angle is only 75 degrees. Only 75. So, you have to, from here, you have to go by 75. Further, you have to go, see, to reach the line of action of resultant, 116.954, you have to go here. Then, along that line, from here, it should be outgoing force. See, from the joint O, it should be outgoing. Same answer. Here, see, outgoing using alpha 2. Now, 1 minute. If this is 63.046, check the answer. Total 180, subtract, you get 116.994 correct. This is using alpha 1. Now I will tell, or I will use alpha 2 and mark it here. See now, once again, alpha 2. First value you got minus 41.954. From the, here, see, from the P2 to the resultant, you took clockwise this way, alpha 2. Answer came minus. Oh, that means it is not clockwise, it is opposite, anti-clockwise. Not this way, you have to go this way by how much? 41.954. Okay, go by 41.954. You got the line of action of resultant from the point O. Resultant should be outgoing. You can't put this way. You can't put that way. It should be what? It should be outgoing. Okay, 86.917 Newton. Or second answer, 138.046. We took alpha 2 from P2 clockwise direction, and how much you got answer? 138.046. But this angle is only 75 degrees. So from here you go 75, you have to go further so that it will come somewhere here, 138.046. Now see, both are same. See here. If it is 63.046, this is 75, you add these two, you will get 138.046. Or if this is 116.954, this is 75, subtract, you will get this angle 41.954. This is correct solution, correct solution. Now, see, now one question which I will usually ask my students. This is outrightly wrong. Don't see, getting angry with this one. You are wrong. You are wrong. Nonsense. Okay. Now, this is correct. I will ask my students. You take one of them minus incoming. You make outgoing by taking minus. Then angle comes minus also. See correctly how you mark the angle. Then extend the line. Somewhere it is outgoing. So this is the angle. That way all your struggle. Answer will come. This I told you earlier. I will ask them. Do you want all this struggling? First of all, do you want to make a mistake? No, sir. Then don't do this way. Okay. But this is correct. But do you want all these strugglings all? Scratching the head, then wondering, etc. Or, I told earlier, you modify this sketch so that no negative sign. You extend this 80 Newton this side. This I told you. So that it is outgoing. Extend one of the forces to other side so that either both are outgoing or both are incoming, and happily solve without any headache. What do you want? Sir, we want that one. Oh, therefore, okay. Therefore, this is correct but not recommended. Okay, leave it now. So for you also I will tell, never go for this one. This is only to show you that solution is correct. Okay, now I will go to the last one. That is option 1 I wrote. Option 2 I will tell highly recommended and most popular and also the best solution. I will write and do it. This I am not removing. Why? I am not removing this one because when I get the answer from here, I want to compare with this one. Answer should come same. Otherwise, you know what I will tell. I will write and do it because why? Explanation not required. Simple. Now, lastly, correct solution only option 2, second option. Best and no confusion. Therefore, highly recommended. This is what you should do if you want to solve this question by law of parallelogram forces. First, remember class. What all I am telling, you should write. Those who are making fair copy from the class. Once again, I am telling. For applying law of parallelogram forces in the format given by me or in the standard format, we want both forces, simple language, okay. People who want technical talking, they should come in front of me and talk. I can talk technically. Both forces should be either outgoing or incoming, or going away from the point or coming towards the point. Now, here 60 is going away from the point, outgoing. 80 is incoming. Once you took this as opposite with minus 80, you know difficulty then. See, answer is still there. But best is, see, this 80 Newton force acting this way, you make a note there. Extend the line, see, this way. You put it like this, see. 60 this way, 80 this way. See, once again, direction should be same. Don't change it. This way only, 80. This you take P1, this you take P2. Now the angle will become, this is 75 means 105 degrees. This if I explain, some will tell you are teaching for primary school students. So 105 degrees. Okay, now both forces are outgoing. Now resultant will go this way, alpha 1, alpha 2. Make this note. All this note you write here, that first of all, this is already covered earlier. We already covered it. But I want neat format. Okay, now P1 equal to 60. I will take P1 60. Okay, ink problem. Okay. I will take P1 equal to 60, P2 equal to 80, theta 105. I will substitute R. I got 86.691 Newton. See there? R. And if I calculate angle alpha 1, So told so many times, I won't explain. Substitute in the formula, 63.046 plus will come. If plus comes, other answer is not required. You can add 180 and write one more answer. That you do only if you get negative answer. Alpha 2 when you substitute, you get 41.954 degrees. Therefore, I will write here now. 1 minute here. Let me see up to where I can write. 1 minute. So that camera problem should not come. 1 minute. Should not have camera problem. After writing everything, I can't rub. Okay. Right here. Therefore, see, conclusion now. First of all, this I need not explain because this is already covered. Therefore, see. Therefore, same way. Resultant as we got, actually I got, you still have to get it, got from correct solution, but option 2, that I told not recommended, right here, best and highly recommended is as shown below. See here, as shown below. This sketch, point O is here, 60 Newton, not required. Other is, come this side, okay. 75, okay. Scale I am not bothered. 80 Newton, point O. Resultant goes, see, it will be, see, 1 minute now. Okay, you can make out later. Angle, see. I considered angle alpha 1 from P1 this way. Yes, positive came, correct. That way, angle is, how much? Where is angle? 63.046 degrees. That's how the resultant is going. Resultant equal to, answer, 86.691 Newton. Okay. Or I considered alpha 2 like this. See there? That also positive, correct. This angle is, if you want, how much? 41.954 degrees. Now do one thing. For checking the answer, if this is, see, this total is 105. From 105 degrees, subtract this one, you get same answer. This answer you can see here, see? You can see here, that answer. 41.954 you can see here, see? You can see it here. Both are visible here. Therefore, this is a final answer, right? Fully correct. What we solved by option 1, which is not recommended, confusion can come, but the procedure is not wrong. But when you solve by simple approach, perfect answer came. Now, I will close this one by checking this answer by resolution. Remember, I will write everything and just show the answer and leave it. I will write everything. That's all. And then I will close the class. But I will write it because I don't have to explain, because resolution all you are covering later. Later you are covering only for information. Okay, now let us verify the result by using principle of resolution. Remember, let us check by resolution. Class, this will be completely covered in the upcoming classes. Still, I have not explained for you resolution. Therefore, whatever I tell you, believe. But almost 99% people know about it. Or briefly I will write, because this also I told many times. Somebody may ask, sir, why? No, why nothing. You ask why later when I explain it. Then why you are doing it? What? You do one thing then. Don't see this one now. After finishing resolution, then come back. You'll be laughing like anything. Oh, you're so easy. So, briefly, see, 60 right equal to 60 right. One thing forgotten. I thought I will not use the pen. But one thing you are right now. See, in the sketch you do one thing. I forgot to write one small thing. One XX, YY you have to mark. Okay. Put the sketch once again. See, XX and YY. I forgot to tell. Okay. Mark that one. XX, YY. Actually, I thought I will not use the pen. Okay, now 80 is coming this way. Angle 75. This all I will tell you. Why 75 is taken. This everything explained. See, this way means down and left. This all will come later. 80 sine 75, 80 cos 75. Okay. Sigma fx, algebraic sum in x direction. I will take right side positive. Plus 60 minus 20.706 is plus 39.294. I want without sign 39.294 to right side. Sigma fy, only one force is there. I will take upward positive, down minus 77.274. So, see, minus came 77.274 down. I will tell one small thing. Long back, when I was taking the class of this type, one of my friend, very close friend, long back, maybe 35 years earlier, he is equally good in structural engineering. Very good concept he has got. He asked me after the class, laughing, Kannada, he told, Yeno idu? What is this? Only one force is there. Why you want to sum up vertical? Sigma y crystal clear, visible, down, right directly. Why you take upward positive and then negative came downwards? I told him, I am taking a class, teaching the students. You do not know the students. If I write that way, they get confused. Every class so far, sir was taking sigma y upward positive. This question you took directly downward. Confusion. You don't know their mentality. Therefore, do you think I am not knowing that much? He told, no, I know it. Then this is for teaching. I got a format. I do not want to deviate. Those who are understanding capacity is there, they will tell, yes sir, clear. Others will tell, yes sir, clear. See, upward you took, negative, down. Okay. Then he told, okay, continue. He told that way. Actually, not that I am not knowing. If I am doing personal calculation, first of all, I won't write anything. Okay, start. Now, sigma fx is right side, sigma fy is down, resultant this way. Remember, now resultant equal to no p1 square, p2 square, 2p1, p2 cos theta, same formula, cos theta is 90 degrees. So, sigma fx square, sigma fy square comes 86.691 Newton, and angle made with the x direction, alpha x this way is tan inverse of, with, if you want angle with x, opposite first, fy by fx, 63.045. Therefore, resultant is this way, 86.691 Newton. Angle from x is 63.046 degrees. Resultant using resolution principle. This will come later in the class. You write there. Later means over. Today's class number 9. Next class 10th is the resolution only. So is as shown. Now do one thing. Observe. Hey, same. 86, 63. 86, 63. 86, 63. Here 63 is not there. Subtract 75. Oh, yes, there. Okay, sorry. Full 103. Oh, it is there. Not that everything should be written. Oh, see the inner brain. That is inner mind, you can see it. Don't tell 63 is not there. This is 138. That is 75 degrees. Subtract. Oh, yes, sir, coming. Yes. Okay, now, that's all. One small information for you. I am winding up law of parallel forces. In this class, I will not take here now objective type question, twisted question. Sometimes they ask, if this force is doubled, what happens? Practically or subject point of view, it is required. Academic also required. That all in the notes I will write. There, you will understand easily. In the notes you can see plenty of questions where I will write there. These are the questions for objective type of examination, or I will write these are for academic purpose. But in the main course, I will give most important to basic concept and thorough understanding of mechanics, engineering mechanics, strength of materials, structural analysis 1 and 2, RCC, steel, etc. It will go. I want to complete even matrix method and also finite element method, structural dynamics, then theory of elasticity. Let me see. It will keep on going. I told, if I get very good support from everybody, now lastly I will tell, see, I uploaded so many classes, but still more and more people are not viewing it. Those who are viewing, they are commenting and they are telling me we are getting great help from you. Reason is simple. It is not known to others. So you people, if you want me to thoroughly continue subject after subject, complete structure engineering, at least some contribution from your side. Not that contribution, that is separate. I won't talk now. At least for making this channel popular, you share with others and tell them to further share. See that this will, what you call it, expand. If you really mind, you can make it to expand for entire world. I know I got that capacity. Okay, thank you. See you in the next class, lecture number 10, where I am starting resolution. Means more and more serious now.